Hi, back again. So we've been talking about the digestive system. Wanted to zoom in here on the small intestine. Let's go inside the small intestine. There's something inside the small intestine. So you've got the smooth muscle of the small intestine, but what's on the inside? You've got the villi. Yes, they're little fibers, right? So kind of projections. They're called the villi. And on the villi, you've got little hair-like structures called the microvilli. So you've got the small intestine, right? Smooth muscle, but there's a lot going on inside, right? So this is where nutrient absorption is really taking place. That's why the small intestine is the place to be for nutrition. So the villi and the microvilli, okay? So that's what we were talking about with the digestive system. All right, so let's take a look at some of these foods that we are trying to turn into energy, right? We mentioned carbohydrates. If I wanted to get a glucose molecule, I might have to eat what would be a sucrose molecule, right? So table sugar. So I've got glucose and I've got fructose, but I'm going to have to break this bond here, which we call the glycosidic bond. And you're going to need enzymes to do this, all right? And we mentioned earlier that vitamin B1, thiamine, is useful as a cofactor for an enzyme called sucrase, which will break this glycosidic bond, forming glucose and fructose. Fructose can be utilized in the liver, right, for energy, and the glucose anywhere in the body, especially the brain. The brain loves glucose, all right? So whether it's in the cyclic form or whether it is in the linear form, it's ready to be used. In another segment, we will see that this 6-carbon glucose in a process called glycolysis, which uses a variety of enzymes, one of them is going to cleave this 6-carbon into two 3-carbon units. So we call this glyceraldehyde, right, when we cut it into these two glyceraldehydes. So when we go and learn about glycolysis, glucose will be cut in half, and then the glyceraldehyde converted to pyruvate, and the pyruvate can then go into the Krebs cycle and create more and more adenosine triphosphate ATP. So we'll learn about that in another talk. All right, so sugars, of course, sugars can come from a variety of foods. Starch, right, can be converted into sugar, and all kinds of fruits and vegetables are useful for getting sugar. What about other molecules that are important? Well, we need more energy molecules. Fats are certainly the highest energy source. A fat molecule is called a triglyceride. I don't know if you can see this on the camera. It looks a little bit funny there, but it has 3 carbons. Glycerol has 3 carbons. Now, the reason I have this is because fat molecules are quite large. So you've got 3 carbons, and there are 3 alcohol groups, each bonded to the carbons. But more importantly, when you put this together in terms of a fat, you've got these long chains of carbons hooked up to the glycerol molecule. So let's see if I can get this to work here. Yes, I'm doing this with some rulers. It's kind of neat when you can play around with these, get them to work. So here I've got the carbons. Here, let's hook this up. So let's see if we can see this. We've got the triglyceride. So we've got the 3 carbons, and to each of these carbons will be hooked a long fatty acid chain. Here, let me just put this down for a second, bend this into shape. I'll show you what I'm talking about. So you've got a series of carbons kind of bent in this angle structure, all right? So a series of carbons. We look at it this way. And some of these fatty acid chains, typically they're around 14 to 20 plus carbons, all right? For example, in beef tallow, I believe there are 18 stearic acid, 18 of these carbons. So, but these are the long chains that are held, right, bonded to these individual carbons. So here we've got the structure of glycerol, right, 3 carbons available. one carbon, right, is going to be bonding to a fatty acid. Another carbon's going to be bonding to a fatty acid, and then the third carbon's bonding to another fatty acid. So 3 fatty acids will be held onto this carbon, 3-carbon backbone. So 3 fatty acids. That's why fats are called triglycerides, 3 fatty acids, all right? And glyceride coming from glycerol. So fatty acids, fats together, a big molecule. Fact is, here, if you like to play with toys, which of course I love to play with toys, whether I'm doing chemistry or physics, teaching people about energy, nutrition. You can imagine playing with this here, and let's see if I can do this. We'll angle it. Yeah, you wouldn't think you could do this with toys. I don't think they put this on the box when I bought it, but you know, that's because I'm the professor who's always coming up with fun ways to entertain and educate. So this is kind of neat. Watch this. At the end, if we can zoom in on this one here, right? See this molecule here? This is a carboxylic acid group. When we say fatty acid, this is the acid part of this fatty acid chain. Fact is, let's put this over here. See if this will be a better backdrop for this. Let's take a look here. Oh, there we go. So we'll put it on this side. How about this? So here we've got one of the fatty acids. So they're long carbon chain, and on the end, that gray plastic piece would be the carboxylic acid portion of the fatty acid chain. So it's a long chain, and at the end, we've got the fatty acid chain, which in turn will be bonded into glycerol, okay? And fats are very high in energy, and you can expect so because you've got all of these carbons available, right? So a gram per gram basis. What other molecules do we have available for energy? Well, we have proteins. But unfortunately, proteins aren't really the best way to get energy. Well, I don't know if I should say unfortunately. Usually you want to get amino acids, all right? So proteins are putting amino acids together. So here, if we have a protein molecule, each one of these is an amino acid. So here's an amino acid bonded to another an amino acid, right? This would be a dipeptide, right? Peptide, proteins, tripeptide, 3 amino acids, 4, 5, 6, 7, 8, and so on, right? So you've got amino acids which hook together to form peptides and polypeptides, all right? You remember polyester? Well, this is called a polypeptide. And then you can form proteins when you start to bend this 2-dimensional structure into 3 dimensions. Well, I guess that broke, but you can see how you can have all of these amino acids available to be put into various structures, and then those proteins can be used for all kinds of things, all right? So for enzymes in particular. So proteins are very useful in that respect, all right? So not really the best thing for energy. Get your energy from carbohydrates and fats, and proteins are going to be useful for muscle building and all kinds of other aspects in the body, all right? So we'll see you in the next segment, all right? Take care. Bye for now.